Hello everybody, this is Eric, and I repair synthesizers and other electronics, things that go wrong around the house or things that catch my eye, old computers, radios, vacuum tube testers. Doesn't really matter. Just some fun stuff to experiment with and work on, sometimes even connect together. So right now, what you see here is a keyboard from an ARP Axxe. It's a monosynth. The keyboard would be very similar to others that came out of the 70s. And this particular keyboard is quite messed up. The bushings are bad, and I'll show you what a bushing looks like and show you some symptoms on the keyboard of what a bad bushing looks like and sounds like. About a dozen of the keys actually had a broken part inside them, which you couldn't tell was broken, so it felt fine just when you played it, but when you opened it up and really took a look at it, you could see a serious problem. The bus bar was heavily corroded, and some of the keys, there's a little plunger that goes into a rubber contact holder for the J wires. Sometimes that holder just falls out. It doesn't stay attached to the key, and when that happens, that key will just take over and always be playing because the J wires become always in contact with the bus. Now, you may be wondering, J wires, bus, key plunger, what is all this stuff? So, since I've got the keyboard right here, I'm going to show you. Alright, so these are the bus bars. Okay, these plastic looking pieces here, those are these rubber contacts, the contact holder. The J wires are also the contacts. They literally go through these rubber contact holders. There's a grid with about 9 holes in it, so you can adjust where the wires penetrate, and then they come out the other side and are right above the bus bars. So when you push a key down, you can see this movement here. This one might be better to show. You can see the J wires come in contact with the bus wire. That makes an electrical circuit. Now there's a couple of things going on here. One is you need a gate signal that says, hey, a key has been pressed, start making sound. And the other signal you need is a voltage signal telling you which key has been pressed and which frequency for the oscillators to make, essentially. So, obviously, very critical. These are precision resistors. Reason for that is all of these keys need to stay in good tune, right? So, you can't have low quality resistors here throwing off the voltage from key to key, because that voltage ultimately is what controls your pitch. Now on the back side of these you'll see all the springs, which give you that nice feel to the keys. And then inside here, and I'll go get one of these because I have a bag full because these all need to be replaced. So in here, you see this little piece. This is a key stop, okay? And on that stopper is a rubber bushing. So you see the skinny metal piece here. See where it gets thicker there? That is actually the bushing. So when you push down, it's silent, and it goes down only so far. And when it comes back up, the bottom part of the key here also hits the bushing, so the key doesn't come up too high. So to show you a bad one, look at this problem right here. This key is high. The reason is there is no bushing in there. None whatsoever. You hear that clack sound. That clack means there's no bushing because it is plastic on metal. Okay. So if you're trying out an old synthesizer and you hear a clacking sound like that, you've got no bushing. And if you see, that you've got a key level problem, that's another indicator that there's no bushing. These are key bushings. You can see the slot, the hole in them, the rectangular hole. So that metal key stop piece goes through there. The key pushes down on the Y shape, so you can see the Y there. So it pushes down, and you get a nice, look at that. It absorbs the key impact nicely. Now these just slip off and on over those metal parts. One thing you do need to do when you're installing them is you need to lubricate these. That'll make them last longer. These are silicone rubber, so silicone grease. I would suggest Dow Corning 7. $20 will get you, more than you will probably ever use, but that's I think about the smallest tube you can buy. You can find it on Amazon. As for these bushings, I actually got these from a guy named Robert, who has a website called Sound Doctoring, and he's got a lot of vintage parts. There's another critical problem I want to explain. I mentioned that there was about a dozen broken keys. Actually, I think there's 10. Anyway, inside, on the bottom of the key, you have a little piece that looks just like this. And it's literally glued on the key body. And this is the piece that goes into that rubber contact holder. Okay? So this is the part, I call it the plunger. When you press the key down, this goes down, pushes the contact holder down, and pushes the J wires into the bus bar, making the electrical circuit, which sends the control voltage signal to the oscillators. So what I had to do was, well, first of all, these are all 3D printed. I've had to make a couple different runs of them in slightly different sizes because of just variations in pieces and parts. So some of these rubber contact holders, one of them I know is loose, and so it will fall off the plunger. And when it falls off the plunger, then nothing is holding the J wires down, and they spring back into position naturally. Actually, they spring down rather, and touch the bus bar, so that key always plays, and you don't want that, of course. So let me show you what these look like in place, the new piece. So this upper key needed one of those. You can see the white one is the original one on one of the keys. See? And the red one is one of my replacement parts. The white ones are also just glued into the key body, so you can just snap them out with a pair of needle nose pliers, file it down a little bit, and then glue in the new part. I've made the designs of these parts public. They are on Tinkercad, and if you take a look at my blog, you can find the designs for them and print them out yourself. I actually print parts at a local library for free. So you can make quite a few good vintage part replacements that way. Buttons, knobs, pieces of the keys. Onto that bus bar. So the bus bar was heavily corroded before I got a hold of it. And I did clean it. Maybe I cleaned it wrong. No going back now. I thought it was brass or copper, and so I used Brasso on it, only to find out it had a beautiful, shiny, gold-plated finish underneath. So I should have used gold polish, apparently. Brasso, for from what I've read since, can be a little harsh, but you know what? It looks good and it works. On to the electronics. The great Robert Moog standardized the industry, because he was first to do it, on the 1 volt per octave system for these keys. So here I've got 3 octaves, okay? So I should have 3 volts across this keyboard. Now, you see this little tangle of wires over here. What I've actually done is taken the plugs, the Molex plugs for the keyboard, and tapped into them. I'll show this a little better. Okay. So we've got a ground connection, of course. We've got a voltage connection. We have an output, which I'll show you what it feeds into in just a second. That output is the control voltage. The ground is, the reference, so the control voltage has something to measure against. And then it just turns out, for the way this particular system works, you actually need a second ground hooked up, and then an input voltage, so you have the full range, so 0 to 3 volts, and then the different keys that you press create that circuit which cuts the voltage. It's a voltage divider circuit if you want to look it up, and that just means you have resistors all in series, all in a circuit, and if you tap in at any joint between resistors, now that circuit, you're reading the voltage at that tap point. That's the voltage that gets sent out to this guy. So this is a vintage modular synthesizer, and I have it hooked up right now to this keyboard. Now, not all of the circuitry is in place, so things are not going to sound exactly right, and there are some problems, but I'll show you how to resolve those as we go through this and talk a little more about the circuit. The first problem is, since I am only powering up and using this as a voltage divider, all I get is the voltage signal. I don't get a gate signal. That causes some problems. Essentially, the keyboard is always on. There's always a 0 volt signal going through to the modular, and the modular, it doesn't know any better. It just does what it's told, and it can have gates and triggers fed into it, but right now I just can't generate them from this. The ARP has a handful of components in its gate circuit that would generate the appropriate signal on a key down, okay? But I don't have that, so it can be a little noisy. I also appear to have I hope it's just a ground loop noise coming out of this synthesizer, because it turns out that I know that the power supply that it's on is on a different circuit than my mixer. The keyboard, thanks to the genius Robert Moog, gives us 1 volt per octave. 3 octave keyboard, I should have 3 volts across it, if I'm in tune at all, or have any chance of being in tune. Alright, so I'm a little low, okay, which is fine. I put a potentiometer in my circuit so I can actually adjust it. You can see how sensitive, again, just a few millivolts throws off the overall range of things. It's super sensitive. This is why it's so hard to tune an analog synth. But step 1 is make sure your keyboard is really putting out 3 volts per octave. Now this is just my test circuit, so this isn't, you know, really the way to do this. But it does demonstrate the challenge that you have. Now if we look an octave lower, 2, 1, should be down around 0. A little high. Okay. So you get it close, and you're still out of tune. So what's going on? Well, this is because my modular is out of tune. It's not because this isn't putting out the right voltage. So I took a look at the modular using a little chromatic tuner here, and what I found is that it's, wow, we've got like about a half step. Eee. You know, I mean, that's not really an octave, but it's closer than the other keys. So tuning the modular, that's a whole nother story, but this will give you some appreciation of thinking of the system holistically, that you start with the keyboard giving you 1 volt per octave. If you don't have that set up right, then you'll never get your modular tuned across the entire range of the keyboard, or any analog synthesizer. They can be hard to tune. Moog Prodigy, great synthesizer, can be really hard to tune, especially over the whole 2 octave range, or 2.5 octaves that it has. That's the problem you run into. You can get it part way tuned, you have a sweet spot, and then it starts to go out of tune at the extreme ends of the keyboard. Sometimes that's all you need, though. We talked about the pieces and parts inside these keyboards. We talked about the bushings in particular, how to detect when they're messed up. You know, from the noise to the visual alignment, bus bars, the J wires, taking care of corrosion, 3D printed parts. If you've got this style of key and you need to fix these little plungers, tell you what, if I bought replacement keys, they're anywhere from like $12 to $15 to $18 a piece. I print these for free. You can print them for free too, or at least get them at a real low cost. Get them from me if you want. And then you don't have to pay those exorbitant prices for the keys that are out there. You can just repair the old ones that you've got. So I hope you're not kicking yourself for throwing out keys that had that part that was broken off, because they're perfectly good. Those little ABS plastic pieces glue on just fine. And that, oh, and of course the whole discussion about how this works, how it interfaces with the modular, and there you have it.